Okay, Wildcats. Today we're looking at Friday, April 12th, modeling real-world data on page 71. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at the examples. Modeling real-world data. Find the function that models the data, write the function that models the data, and then predict. Example 1. The table shows the population growth of Temple Wildcat population. Okay, so the first thing we're going to do is we're going to find the correlations for linear, quadratic, and exponential. We're going to use our calculator for that, okay? All right, so we're going to go to New Document, No, Add List in Spreadsheets, X, Y, and then we're going to put in 1, okay, and then we're going to put in 662, 740, 825, 908, 1003, 1095, and 1200. Okay, once you do that, we're going to go to C1, and then go to Menu, Statistics, Stat Calculation, and then we're going to go to Linear Regression, X, Y, enter once, twice. We're going to go down to the R value, which is 0.998. So let's round up the 3 decimal places, 0.999. Okay. All right. Now we're going to click to the right, go up, Menu, Statistics, Stat Calculation. Now, from the previous lesson, you know that I accidentally went to quartic. Okay. We don't want to do that. We want to make sure you pick quadratic number 6. X, Y, enter once, twice, and again you're verifying it says quad, not quart. Go down to the R squared value, which is 0. And actually that's somewhat repeating, so 0.999 repeating. Actually, no, I'm sorry, that isn't repeating. That rounded to that line. This one's repeating because of 99999 and so on. Okay. All right. Now we're going to click to the right. We're going to go up to I1, and then we're going to go to Menu, Statistics, Stat Calculation, and then we're going to go to Exponential. Okay, X, Y, press Enter twice. We're going to go to the R value, which is 0.999. Okay. All right. Now, the problem you have is, in essence, it's saying the R value is almost the same. Okay. So when it comes to that, you look at the problem. Whenever they're talking about population growth, we're talking about exponential. And that's why you know it's exponential. Okay. Now to write the equation, let's do that. So we know exponential is y equals a times b to the x. And let's go to our calculator to find out what the a and b values are. So here they are right here. So it looks like a is 657 point, let's just do 0.3, and b is 1.0. Let's do 2 decimal places on both. So 6a is 657.31, and b is 1.02. Okay, so now our equation is y equals 657.31 times 1.02 to the x power. Okay. Now it says use your model to predict the population in 2020. Okay. Now to understand that, okay, so years after 1974, okay, so we know that one would be 1975, okay, and here you can kind of see where that math comes in. So what we can do here to find out is 1974 plus, and actually that wouldn't make much sense to do plus. What would be better is if we subtracted. We want to take 2020 minus 1974, which equals 46. Okay, and we can check the math by doing 1975 minus 1974, and that equals 1. So the logic here works. Okay, so our value for x is going to be 46. So in the calculator, we're going to write y equals 657.31 times 1.02 to the 46th power. So let's do that and find out what the population is. Okay, so we're going to go to on, new documents, no, add calculator. So 657.31 parentheses 1.02 raised to the 46 is 1,634. But because we're talking about population, we're going to round it to a whole number. So the population is 1,634. Okay. So you want to conclude with a sentence. So you would say the population, I should say the wildcat population will be 1,634 in 2020. Okay, so go ahead and finish up example 1. All right, now let's take a look at example 2. All right, the table below lists the total estimated number of wildcat blue cases by year of diagnosis from 1999 to 2003 in Temple, Texas. Wildcat blue is when you turn blue from overexposure to wildcat school spirit. Okay. All right. So first thing we do is I'm going to explain what I've added here in a few minutes, but we're just going to look at the initial table. Okay. So to find the correlations, we're going to go to on, new document, no, add list and spreadsheets, X, Y, and then to make things easier, I'm going to make 1999 0, 2001, 2001 2, 3, 4. So in our table is 0, 1, 2, 3, 4. Okay. And then our population 4,000. Don't put commas. If you do, the calculator will give you an error. It doesn't accept commas. Don't know why. It just doesn't. All right. By the way, this is the most common mistake students make when doing this. Is they forget to press enter on the last number. If you don't press enter here, it will give you an error. So you have to make sure you press enter here. Okay. Now we're going to go to up to C1, menu, statistics, stat calculation. We're going to do linear regression. X, Y, enter it twice. Our R value is 0.634. Okay. All right, now we're going to click to the right, go up to F1, menu, statistics, stat calculation. We're going to go to quadratic regression, X, y, enter once, twice, go to the r squared value, 0.903. And then we're going to click to the right, menu, statistics, stat calculation. Now we're going to go to exponential regression. X, Y, enter once, twice. We're going to go to the R value 0.631. Okay. All right. So it looks like here that it's a quadratic regression. Now let's write the function that models the data. Now we know if it's quadratic, the equation is y equals a x squared plus bx plus c. Oh, back the camera there. Okay, so let's change that to there. All right. So now we need to find the a value, the b value, and the c value. So let's come to our calculator. Okay, so let's go back to the quadratic. And so let's, I probably shouldn't have wrote a, b, and c first. I should have waited. And it looks like these numbers are a little big, so I'm going to do a here, b here, and I'll do c here. Okay, so a is 345.14. Okay, b is negative 1015.37, and c is 41,543.10. Okay, so our equation is y equals 345.14x squared minus 1015.37x. And I'm going to extend this line because the equation is getting long, plus 41,543.10. All right. Now we're going to use this equation to predict the number of cases in 2020. Okay. All right. So this is where this comes in. So in 2020, we need to know the years. Okay. So what I've done is I expanded that. Well, if 4 is 2003, then 5 would be 2004, 6 would be 2005, so on, till you get to 21 would be 2020. And so that's going to be your x value here. X equals 21. Okay. So we're going to substitute 21 in for x. So y equals 345, x, or no, not x, 21 squared minus 1015.37 times 21 plus 41,543.10. So when you plug that into your calculator, you get 172,427. Okay, so you want to conclude with a statement. So you would say that there will be 172,427 blue cases in 2020. All right, so if you would, go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat day.